Hello everyone, today we're going to solve weakest k rows in a matrix. So we're given an m by n matrix. The matrix consists of ones and zeros, right? The soldiers, which are the ones, are positioned in front of the civilians, right? So for each row I is weaker than row j if the number of soldiers in row I is less than j, or both rows have the same number of soldiers, but j is the later row, right? So just to summarize, we're given a 2D matrix, and I is weaker than j if the soldiers in I is less than j, or the number of soldiers are equal but j is bigger than I. So the way we're going to approach this is first we're going to count the number of ones using binary search, right? And then we're going to use a max heap. And if you're wondering why we would use a max heap, because we know inserting an element in a heap would give us log the size of the heap, right? Log size of the heap. If we use a min heap, we would have to keep track of all the elements in the like all the elements, the rows. We would have to keep track of all of that. But if we use a max heap, and if the heap exceeds the size of k, we would just remove that extra element. We would save up some time, right? So yeah, so that's pretty much what we have to do. Here's the way how I implemented binary search. If you're interested, you can pause the video here and see this, how it works. It might help. So yeah, let's go ahead and implement that. So yeah, first thing we're going to implement is binary search. So private int count ones, and the input for this function is going to be a 1D array, right? So int row, so int low equals 0, int high equals row.length -1, while low is smaller than or equal to high. We're going to calculate mid, int mid. Let's actually call them L, H, and M for ease. So M is going to equal low plus high minus low over 2. The way why I calculated like this instead of low plus high over 2 is that sometimes when the array is too big, this might lead to an integer overflow. It wouldn't do that here because, as we can see, like n and m are pretty small, but you know, it's just better practice in general. So yeah, so we calculated mid. So if row of mid equals 1, we would set low to mid plus 1, right? Other than that, we're going to set high to be equal to mid minus 1, like just standard binary search, and we're going to return low, right? Yeah, return low. We'll return L and H and L. Yeah, so I forgot. It's okay. So now what we need to do is to use a max priority queue, right? So we're going to define that here, priority queue of type pair, because we have to keep track of the row, the row index, and also how many ones are inside of this row. So we have to use a pair in this priority queue, right? So max heap, right, equal new priority queue. So here we have to implement the comparator, right? So we're given A and B, right? So we're given A and B. So the first thing, if number of soldiers aren't equal, right? And if number of soldiers are equal. So if the number of soldiers are equal, we have to sort it in descending order, since we want like to set the the max element to be the one with the max number of soldiers, right? So to do this, actually the pair for the key, it's going to be like the row index, and for the value it's going to be the number of soldiers in this row. So yeah, if a.getValue doesn't equal b.getValue, that means we would return b.getValue minus a.getValue, right? So that means this means it's going to be sorted in descending order according to the number of soldiers, right? Other than that, we would have to sort by the row index if the number of soldiers are equal. So we're going to sort it in descending order as well. So yeah, this comment should be here, right? So we're going to do b.getKey, right, minus a.getKey. So that's for the queue, right? After we've implemented the priority queue, we should insert like the row index and the number of ones in each row, right? So we should do it like that for int row in matrix, right? And we need to keep track of the counter. Int counter equals 0. So we have to insert those into the heap, right? So max heap.add new pair, since we're using a pair in the heap, and then we're going to use counter and increment it after every operation. And then for the value, we said the value is going to be the number of soldiers, which we already defined in this function, how to calculate it in this function. So count ones of this current row we're working on, right? So yeah, that seems fine. If the heap size, max heap.size, is bigger than k, that means we have more than what we need we have more than what we need to return, so we would just remove that from the heap, right? So yeah, our heap right now is ready. All we have to do is just remove all the elements from the heap, and since we're required to like return the weakest rows first, so we would have to reverse the order of removing elements from the heap, right? Hopefully that makes sense. So int array result equals new int of size k, right? So for int I equals k minus 1, I small than bigger than or equal to 0, I minus minus. So we're going to set result of I equals max heap dot o dot get key, since we're looking for the index, which in this case is the key of the pair located in the priority queue, right? So yeah, that shall be good. Return results, and I'm pretty sure I missed on a lot of semicolons here, but we'll see. So equals, not equal, and actually here it should be called L and H, right? What else? There's something wrong here. A.getValue, yeah, that's a function. And yeah, it worked. Let's submit. Okay, so for the time and space complexity, assuming that n is the number of rows and m is the number of columns, for the binary search we're going to do log m operations, and then we're going to do that for all the rows, so that's n log m, right? So for the heap insertions, we know inserting an element in the heap is going to be log k, right? And we do that n times, but we know actually that log m is always going to be bigger than log k, because that was mentioned here. Yeah, so it's going to be less than or equal to m. K is always going to be less than or equal to m, so we can actually just cancel this out, right? And for the time complexity is going to be big O of k, so since all the extra space we're using is just for the k elements stored in the priority queue, technically the priority queue is going to hold at most k+1 elements. So yeah, that's big O of k for the space complexity. So yeah, hopefully that was easy to understand, and see you in the next one.